Well, hi, good morning, and thanks so much for joining me in my shop here. Today is Saturday, October 17th. So yesterday I replaced the output transformer on the speaker at the back there, and that worked just fine. It was great. So that issue is done and gone. So what I want to pursue today, I think, is the 31 meter band, 9 megahertz band, which appears to be almost non-responsive relative to all the other bands. So why that is exactly, I have no idea. I'm really not too sure just what could happen to one band that wouldn't happen to all the bands, but one possibility is very bad alignment. That's a possibility. And this issue around is the local oscillator above or below the target frequency. Where is it supposed to be? Where is it actually? Has this radio been misaligned really terribly on the 31 meter band? So I previously explored this question. I did it on video, so you would have watched it if you've watched this series. And I got kind of a confused result. Here's the note, my note there. Broadcast band below, 31 meter band below, 19 meter band below, 25 meter band above. So that doesn't jive at all with the behavior of the radio. 25 meter band seemed to be working quite fine. Seemed to be. And so if this one's aligned wrong, why is it so loud? And if this one's aligned right, why is it so quiet? Could there be other component issues? Some component that's related only to this band? Yeah, my thoughts were just running around there in my head for a moment, but I've stopped them now. So I think the first thing I want to do is I want to repeat this analysis of the local oscillator relative to the target frequency. Is it above or is it below? And my expectation is it should be the same on every band. I would really be surprised if for some reason one band has a local oscillator in the wrong spot. I mean, on purpose, like a factory setting like that. An error in subsequent alignment is possible. An error in the factory during the alignment is not very likely. You can imagine there's some guy sitting there back then spending all day aligning one radio after another that's coming onto his bench. And doing them one after another. And it's hard to believe it would come out of the factory and not working right. So, okay, so strangeness all around. The main strangeness is the weakness of this band. So I'm going to do most of this off camera because I've done it once on camera already, but if anything interesting shows up, I'll be sure to turn on my cameras. Oh, okay, so I've decided I'm going to show you the how I'm doing this. Before I do it, I've just turned on the camera again, so I'm going to start up the radio. No, you know what? Don't start the radio up. First, I'm going to show you the SDR. Oh my gosh, Jim, you got to explain things a little more. So I'm using a SDR radio. This is the antenna connection right here to the SDR radio, which is a little box sitting just up here. SDR radio is a software-defined radio. It's a radio. It does not detect signals the same way that one of these guys does. It's a totally different thing, just using computer cleverness. So this amounts to the antenna to that radio, and that radio was going to put something on the screen here shortly for you to look at. And all I'm doing is just throwing this as a loop kind of in the back of the radio here, where I imagine the local oscillator signal is floating around and can be picked up quite easily. So now what I'm going to do is I'm going to flip to the screen that goes with my SDR radio, explain it very briefly, and then I'm going to turn this radio on, flip it to the 31 megahertz band, and we're going to watch for the local oscillator to appear somewhere on the SDR. Now, part of the challenge here is, even though the radio says it's tuned to 9.5 on this band, it may not be. The local oscillator may be somewhere way off from there. I don't know. So there's kind of question marks everywhere. Let's take a look at this SDR. So this is a cheap $25 SDR radio, and you can see I've got it tuned to 96 9.6 megahertz, and you can see the red line and you can see a white line. Let me just move the tuning line off, the red one. So what is this? So my radio right now is picking up something at 9600 kilohertz, 9600 kilohertz, and let me just turn the sound on. It's nothing but that. I'll switch to upper sideband here briefly. Maybe lower. Maybe CW. Back to AM. So I was looking to see if there was maybe a single sideband signal here. It's in the middle of the shortwave band, so there shouldn't be. Sometimes there's communications. Let me just silence that. So I don't know what this is. So, but we know now we can ignore this. This is why I don't have the radio on right now. If I flip the radio on and then turn to this 9600 signal will look like something coming out of the radio, and it just helped to confuse me. So there we are. I'm going to wave the clip lead around the antenna basically to the SDR. I'm going to see if it does anything. For all I know, that signal is coming right out of the SDR itself. So I'm waving this thing around, it's doing nothing. I'm going to disconnect the antenna here. So there's nothing plugged into the SDR, and that signal is still there. So, you know, cheap SDR. Yeah, so yeah, I've learned from using this that you really gotta take everything with a grain of salt. You can get some interesting stuff out of the SDR, but lots of confusion goes on. So we're ready now to flip on the radio. So I'm going to let you stare at this. I'm expecting another tall signal similar to this one to appear. The radio dial setting is 9.5. So theoretically, with an IF of 455, it should be 9955. 9955, which would be way up around here. So, oh, way up around here. So watch for something appearing here when I flip on the radio. Okay, checking the volume. Here we go. She's on. Wrong band. Let me get it on the right band. There we are. Correct band. And we'll just let the radio warm up. I'll put the volume up a bit so you can hear it. It's very weak on this band, right? It's coming. So that was pretty interesting. I wasn't touching anything. The radio came to life, and for that moment you could hear it come out of the speaker, that little hissy sound, just for a few seconds. And then it seemed to fade right down. That's pretty curious. Now you can see, look at all the signals that appear here. One of those is supposedly the local oscillator, but there's nothing really right around the area I'm expecting it to be. And ignoring that 9600 signal. So what I'm going to do is I'm going to tune the radio slightly. This will cause a local oscillator frequency to vary. It should show up on the screen as a moving frequency, but I have the feeling a lot of these lines are going to move. Here we go. Okay, so I'm tuning. So now there is something right in the zone where we expect the local oscillator to be. And it will be right on 10 right now. So it's not a very strong signal. Many of the other signals on here are strong. You notice a couple of the new signals didn't vary when I tuned the radio. So we have the local oscillator set to 10 megahertz. Let me get it exact. As exact as I can anyway. 10. Okay, so there we are. So look, it's a little tricky to see, but there's a little peak right here on 10. I think that's a local oscillator. If the local oscillator is at 10, then the radio should be, and the local oscillator runs above the target frequency normally, then we would expect this radio to respond to a signal at 455 kilohertz less than 10. So that'd be 9545. 9545. 9545. That's way down here. 9545. It's somewhere in here, right? 9545. Does that make sense? Did I do that right? Just a quick math. If you take 9545 and add 455 to it, you get 10. So this radio should respond to a signal at 9545. Let me stick it right there. There we are. So see the red line now is sitting at 9545. So now I'm going to flip back to the other camera. Okay, so remember, with this here, the radio is trying to pick a signal up at 9545. 9545 up here. See, I'm getting confused. Doesn't take much. So we're going to go hunt for it now. So output of this signal generator is on the end of these wires, which I'm going to you know, that's kind of interesting. So what's happening here is I just realized I've left this radio connected to an antenna all this time. I'm going to disconnect it. I don't think it made any much difference. What happened to that 9600 signal? Did it go away? No, that shouldn't. No, it's still there. I can see it. Okay, antenna off, and we'll put on the signal generator here. So I'll be able to feed in basically fake radio signals. Basically fake radio signals. And we want 9545. Okay, I turn the radio up. It is up. Full blast. Can't hear a thing. I'm going to go past 9545 and see what happens. There's a weak signal coming from let me just step it up a little bit. Well, I didn't hear a thing. But the radio is quite insensitive. Oh, 10. What am I doing here? Hang on. Oh, okay, so it picked that up. So that all makes sense, doesn't it? That puts the local oscillator above. Well, right now it's above. Local oscillator. Here, let me just get my head together here. I don't think I can do it. Well, let's go back and look at the SDR for a minute. Okay, so I'm going to wiggle the frequency generator around, and you should see it on there somewhere. You hear it. I think it's visible, but it's very weak. I'm going to step it up here for a moment. There it is. Do you see it on the screen now? I'm going to vary the frequency. Okay, now this is stupidly loud. So you know what I'm going to do? I'm going to disconnect it from the antenna directly. So now it's got a weaker connection to the antenna. Still going to scream in. Oh, we can't. Oh yes, you can still see it. I'll move it slowly. It's right at the left of the blue bar. Now we're going to come to the right. We're going to stop at 9500. And I'm going to look over at the frequency counter, and it says 9494, so that's 9500. Okay, just making sure. It's a little loud. Turn down the radio here. Yeah, that's an option. Turn down the volume. Well, okay, so I'm looking very carefully at where that frequency actually is. Okay. Oh. Hold on a second here, everybody. I tripped on a wire. I disconnected one of my cameras, but I don't think it matters for the video right now. Okay, so what do we got going here? So the signal's right here. .535. Did I just make a math error? 9535. Is that for sure? Okay, let me just wiggle this tuning a little bit again. No, I gotta wiggle the signal generator just a wee bit. I picked the wrong thing there, didn't I? Okay, so this is the actual signal here. Get on there. Ah! Just shifted everything by accident. 9515. But is the oscillator really at... No, I've retuned the radio, so what's the oscillator at now? Oh my gosh, I buggered this up. That's why I wasn't going to put this on video. I'm just going to have all this fun to myself. Okay, I'm going to wiggle the local oscillator. Oh my god, look at everything going every which way. Oh my gosh. It's supposed to be up near 10. Okay, so there's something near 10, but it's not at 10. I'm going to put it at 10. We're going to assume that that thing that's at 10 megahertz is the local oscillator. Unfortunately, we have to make an assumption of that. So now the radio should be picking up, what was it, 9545. How come I can still hear? How come I can still hear this? Just trying to tune it to the loudest spot. I'd say there. 9520 is what it shows on my signal generator. 9520. So if you add 455 to this, oh my gosh, you get 975. 25 kilohertz below 10. Did I not get this on 10? What did I do here? Is that not the local oscillator? Okay, I'm wiggling the tuning of the radio again to spot the local oscillator. Oh my gosh. Oh, what just zoomed up there? What happened there? Suddenly there's something really big at 10 now. I don't know what happened. I don't think I was doing anything. Assumably the local oscillator is really on 10 now. I don't think this is working out at all. This is not working out at all. Because 9545 would be up there. 455 is going to get you to 10. So this is starting to suggest that the IF is misaligned. I don't think it is. Oh my gosh. That's the 9600. Well, this is just telling me the IF is not aligned properly. I don't think there's any other way for this to happen. And why signals are getting stronger and weaker? I'm just standing here looking at them. And what is this huge signal down here? What the heck is this thing down here? Be very careful when using the SDR to do these things, because so I'm going to tune the radio quite a bit here. Like if I didn't know any better, if I were just looking at this SDR screen, knowing what I'm doing with the radio, I would say the local oscillator is this thing over here. Can that possibly be the case? Oh, wow. So if this were the local oscillator, this radio is tuned to 8, 7 something. 455 below that, that's 155, so it's 3, so it's 8700. Okay, so if I pump in an 8700 signal, Does the radio respond? Remember, we're doing this with the volume up nearly full on this band. So, I mean, it could be, well, I don't know. Let's go. 80, what did I say? 8700. Okay, so I'm going to tune the signal generator to 8700, which is a bit of a journey here. Oh. That's 4.8. $8 million rather. 3, 4, 5. Wow. Okay. Believe me when I say that is now an 8700 kilohertz signal. That's the local oscillator? Way the heck down there? The signal strength is enormous compared to every other signal. In decibels, it's going off the top, so it's probably 40, 50 dB above anything else, even more. It's huge. So this is why this band is not working. This thing is just 60,000 miles out. So right now with the radio dialed, it's dialed at 9.6. So you add 455 and you get 10 point something. You sure don't get. You sure don't get. Let me tune the radio farther. Okay, so that's the end of the run there. I can't get any further. Or is the local oscillator running below here? Is this what the truth is? The local oscillator is below? Is there any other huge signals in the area? Let me just slide the whole scale upwards. Nothing down here. Nope. A lot of strange stuff. There's the big whopper. Right here. Is there anything up above? That's the lone guy. He's got to be the guy. He's got to be the guy. Oh my gosh. Well, the thing to do is to try to move this all the way up to where it should be. Above? Now before, when I did the study below, when I did this same sort of study before, at the end of it, I don't think I said anything, but I went away thinking, boy, I don't think that really worked out well. So maybe there's lots of confusion in this radio, some of it stemming from me and my activities here. Okay, so if we want to adjust the oscillator on this band, I have to check the I have to check something. Yeah, let's do that. I'm going to stop for a minute and then we're going to do the oscillator on this band and try to push this thing up into the realm of where it should be and then see if the radio operates better. Okay, looking at some of the information for this radio, this is the 31 meter band oscillator adjustment right here. But look, this is the one that does another band, the C band, and then you further do the C band up here like a sub-trimmer. But this is what's so weird. This sub-trimmer is right on the main trimmer, main tuning capacitor. You got me how this is supposed to work exactly. Maybe this is all the confusion here. So adjusting this one is affecting this band too. And that might be affecting even more in the radio. I'm not sure about that. Let's so getting this right is really, really critical. L17 and L18 and L17 is here. Why does it say L18? Why would it say that? I can't remember now. This guy has two numbers. That's kind of weird. L18. Okay, I'm going to adjust this one. I'm going to have to sort out what this L18 thing is. Let's sort it out right now. Hang on. L18. L18. There's 17. There's 18. So what's happening here is this is a center tapped coil with one adjustment. That's what this symbolizes here. One adjustment, and that's why it's doing two bands. It's not why it's doing two bands. It has been designed that way. So okay, that's what's happening. Then the C band is further adjusted somewhere here. Okay. Okay. I know what to adjust. Let's go back to the camera for a minute. Okay, so the objective now is to move that large signal on the SDR, the one that's right here, move it way over into this area here with the radio tuned. Well, let's be more precise. If I tune the radio to 9500, which I'm going to do right now, 9500, then we would want the local oscillator, wow, that's a long ways, to be 9955. So I'll mark 9955 on here by putting the tuning bar there for the SDR. That's where we want this signal to go all the way up there. Oh yeah, really? Okay, let's see. Maybe it'll go that far. When I look at there's four slugs back here. A little hard to see in the camera. They're all lined up. One of them is sticking up a little more than the rest. And that's, guess what? That's this one. That's the one we're interested in. So I'm going to take a guess that turning this down is going to move that signal to the right. It goes to the left. No. Oh my gosh, what is happening? Now, this is going to come all the way out of the radio at this point. Okay, I'm going to get there. Oh my gosh, you can't, well, you can see how, you can't quite see. This is now sticking way up. Okay, but this is the spot. Back. SDR has about a 1 second, almost a 1 second delay. So theoretically now, this radio is tuned to 9500. Oh yeah? Oh. Look at the volume difference here. This radio is silent. This is volume. Oh, I think I'm onto something here. Definitely. So, dirty volume control. 9500, eh? So this is a moderately strong signal loosely coupled to the antenna. I think it should be much stronger. Son of a gun. Okay, so I'm going to swing the camera over here. Oh, what happened there? I just touched. I just touched this. That's sounding pretty good, except where did the oh, it's right here. Okay, still not turned up very high. Let's put an antenna on this. Put an antenna on it. That's the sound of an old man bending over. Okay, so this is an outdoor antenna. We're gonna take off the signal generator here, which, look at that, even and it's not even what we're hearing. What's going on, Jim? Volume down. And I'm pretty sure the antenna is switched off. Let's see what we get anyway. The lead in itself can act as an antenna. What kind of funny business is going on with that signal generator? Something's very microphonic. And just for that purpose, I have my microphonic checker. Oh my gosh, I get a chance to use it. Tuning fork. Let's see what we can do with this. I'm going to give it a whack, and then I'm going to touch it on different things. We'll see if we can figure out what's doing it. That's not quite what I expect here. I've got a tube here. I just touched the tube, and I think this might explain what is wonky in the radio. Swing this around. This guy here. That's not good. So is it a pin connection in here that's bad, or is it I'm wiggling the connections underneath the radio, and there's a cold joint in there or something? That would be the question. Turn the power off, pop this tube out. Let's take a look at it. Ooh, it's hot one. How come that tube got so hot? She's a hot one. Alright. As usual, the pins look just fine on here. Maybe just taking it out and putting it in a couple of times. Being a little more vigorous with it. So if it's a contact problem, pretty much eliminate it this way. Okay, let's try that. So that's probably what's been going on. This wheel is bumping the tube a little bit, and so occasionally I'm turning this, I'm maybe bumping the tube a little bit. Something like that. Here we are. So yeah, just okay. Let's go back to playing with the radio. I think it's okay. Nine 9.5. So the radio is receiving 9.5 at 9.5. It could be because I got the local oscillator on the wrong side now, but the signal's strong enough. We really need to pick up something from an antenna. Okay, so as I often do, I have to run through my house and flip a switch. Okay. So the antenna is loosely coupled here. Let me unloose it. Somebody. Anybody. It's either Radio Cuba, Radio Marti. 9-6, 965, 9-7. How do we know this is being received in the right spot? It's not one thing, it's something else. It's receiving. Volume's not extraordinarily high. That's okay. So I think I did the radio a favor, and I got the local oscillator on the same side as all the rest of the bands. That's not true. So previously I assessed this band and discovered the local oscillator was where it should be, above. But now, today, I've discovered no, it's actually way below. How many more of these are like that? So all the other bands are responding. This guy's receiving now. You know, it's 10 in the morning. It's not exactly the best time for listening to shortwave. In fact, shortwave's really been weak the last while. Let's just listen to the other bands here, briefly. The volume about the same level here, and we get about the same kind of noise. Put it at 11.8. Oh, I think I hear my cat coming. 11.8. Hmm. 12.4. So 12.4 is way out here somewhere. Way out here. Ah, this is one badly aligned radio. Maybe I really messed it up last time by not properly identifying the local oscillator. So where 12.5 actually does show up down here. Let's go down there. Oh, this band's gone silent. Because you know I moved the local oscillator way off on here and that affects this C band. I don't think my cat cares about this. So volume's up full now. Oh my gosh, there it was.
That's absolutely awful. The Hindu gentleman finished his story by saying, "You think your Jesus suffered? It was nothing compared to what my holy man went through." Now, Matt was shocked and appalled. He had to agree that, yes, he had gone through.
This is roughly 9.3 where there's a very strong station. This is probably it. It's exceptionally strong. So, turn it up high enough. That's full. Okay, so I'm going to go and settle my cat down. I think what all this is telling me is that I got to go through the alignment process again, band by band, step by step, very carefully. Yeah, each time accurately verifying where the local oscillator is actually at, and trying not to be confused by the SDR display. And even if the oscillator is so far out that it's in a place where you just wouldn't even imagine, I have to go and find it and get it to where it needs to go. But first, I'm gonna go play with my cat. Okay, so here's the unexplainable result I got from that. So what I did is I looked on my SDR to spot what I'm quite certain is a local oscillator frequency. There are so many ghostly frequencies floating around in the SDR, it's easy to get it wrong, obviously, I guess, for me anyway. So let's just start with this one. 31 meter band. When you tune to 9.5, the oscillator runs at 9.960. That's a difference of 460. That's right there. That's great. You're correct. Or very, very, very close. Okay, look at the broadcast band. You tune to 1 megahertz. The local oscillator is running at 1.429, 430 kilohertz. Not quite the 455. Put a smaller check mark here though. Band C, when you tune it to 10 megahertz, the local oscillator is at 10.333. I think that's an X. It should be at 10.455. Or maybe it's 460 for this radio. We go down to the 25 meter band. We tune the radio to 11.8 on the dial, and the local oscillator is running a megahertz above, 12.875. A megahertz off. Wrong. And if we look at the 19 meter band, we see when we tune the radio on the dial to 15.2, the local oscillator is running right there, just about 15.2. No way. How it all got to be this way? Am I the guy who did this previously, fiddling around with it? Did I align this radio seriously? Make an attempt at it? I can't even remember now. So the way I want to approach this is first I want to verify that the IF is 455 or 460, whatever it should be, and then from there I just got to go band by band. Yeah, they think this isn't even above or below. This is on top. This is double above. This is proper. 1 IF above. This is proper but needs some tuning. And this one is, well, it's above. Maybe it's just a little out. How did all these things get to be just a little out like that? Actually, that's more than a little. Anyway, a mess. This indicates that this radio is a real mess. That seems to be what I've discovered today. So that's what I'm going to do. 455. Well, I'll make sure what the I'll find out what the IF really should be, and then we'll just verify it. Okay, so just thinking about this a little bit further, in the order of alignment. First you do the broadcast band, then you do the 31 meter band, then you do the C band. The C band is affected by the adjustment here of the 31 meter band. The C band adjustment is right on the capacitor. It's one of the capacitor trimmers, the tuning capacitor trimmers. That means the C adjustment is then affecting everything else after that. So what happens if you get the 31 wrong? If you get the 31 wrong, then you're going to get the C wrong, and you're going to get the tuning capacitor trimmer wrong, and everything's going to be wrong after that. So what I've done today is I've corrected the 31 meter band, and in doing that, that is what has made all these other ones go way out. Because I say so. That's my thinking. So if I'm correct, if I make doubly sure, it's 460 by the way. 460 is the IF frequency. If I make doubly sure this is correct, and then follow the steps very carefully, I should be able to bring all the rest back into the proper zone. That's what I'm thinking. It's not like aligning one band has no effect on the others. It seems to be this one here is absolutely critical. Okay, I think I know what I'm doing. my camera got excited there. You know what's happening? It's stumbling on the pattern here, the cross pattern. It can't focus well on something like that. Sometimes I have materials in here. Sometimes like the back of a radio dial has, or the speaker or something has a pattern on it, and the camera can't handle it. Hey, everything. Okay, so what I'm gonna do, right? I can do the IF thing right now. Nothing special has to be done to do that. Turn the radio up. Turn this down here. So I dial up 460 with a strong signal. We should hear something come from the radio. I'll try it right here. No, that's a coincidence. That music is a coincidence. Let's put that there. 460. Maybe not strong enough. Hello. Hello. Not showing up. I need to inject it more directly. So I'm going to take the antenna off. That's right, yeah. I'm going to put the signal generator right on. Oh, you can hear it now. So now we're getting enough signal into the IF. Tuning the radio shouldn't matter. Is it 460? The swoosh at 460 is interesting. Yeah, it's tuned to 460. So nothing wrong with the IF. The IF is not part of the picture here. So it's just a matter of starting over again and doing the entire alignment, doing it very carefully, making sure I get the right local oscillator, making sure I recognize the true local oscillator frequency, and we'll see what comes out at the end of all that. Okay, first band done. That's the broadcast band. Quite a bit of adjustments for them to be done all together. 2 oscillator adjustments, an inductor at the bottom and a capacitor at the top. I must have gone back and forth here a dozen times to try to get this to fit fairly well. Let's check it out now. It's on an outdoor antenna. So this is 590 coming in. Just a little off.
Speak at all. Our goal is finding beautiful SMD source.
640. So it's right on 640.
And we're pretty nice to boot.
680. Right on the edge of some noise. It's a tricky one to pick up. Okay, now from here, some radios don't pick up anything more. Let's see what this one can do. I think that's 740. 750 on the dial. This is the French station that sort of halfway radios can pick this one. This guy's picking it up quite good. The station's not coming from Quebec. It's here in Ontario somewhere. I don't think I pick anything more up. That could be 1150 from Hamilton, Ontario. getting a little quiet. It's quieting right off. Compensate with a bit of volume. Well, okay, so hey, I got one band done. Maybe I think the first time I did the alignment it was a quickie, just to make sure things were working. And this is not a quickie. It took quite a bit of time for that. So next band is, well, I think it's the 31 meter band next. Let me just take a peek and see. 31 meter band next. That guy right there. Okay, we'll work away at that. Okay, that's it. I've done every band. I've moved the local oscillator to 460 above the target frequency on all bands. They're all done. They were all way out. It's kind of crazy. Very, very crazy. Now we're going to have a little listening test, and then I'm done for today in here. So let's put the antenna on. Okay. Still hear the signal generator. Turn right down. Okay. So you're definitely on the antenna. Okay, let's start with this top band, 15 megahertz band. Not exactly. Well, it's a little after noon now. There might be some stuff up here. So this is pretty certain to be coming from Saudi Arabia. Saudi Arabia has very strong transmitters, and they transmit the singing of the Quran. You can pretty much get it any time of day, somewhere. So that's probably a 500 megawatt, 500 kilowatt transmitter doing that. Nobody else going to make an appearance. There's probably a strong signal at 15770, which is way over here. And of course there's WWV, that's down here. But WWV is hard to pick up these days. Okay, next band. Phonograph. 25 meter band. What do we get here?
Proceso de confirmación a la Corte Suprema de Justicia.
So you can check out the volume control here, get an idea how strong the reception is.
De octubre para decidir el futuro de su.
Barely turning.
Abra paso a la fase final
Excellent.
en pleno del Senado.
And this is history being made, folks.
Y esto es historia, amigos. Esta es la primera vez en la historia de
So that's
Estados
almost
Unidos
certainly
que
Radio
nominamos a
Marty,
una mujer que es abiertamente
since I'm sure I just heard an American politician's voice
ella va a
there.
ir a la corte.
Lindsey
La
Graham.
emoción generada por la nominación elección presidencial del 3 de noviembre puede tener consecuencias que
Yeah,
podrían
it's always
afectar
picked
el
up twice.
balance del máximo tribunal, indicó a la.
It's working pretty good. I think it's picking up what's there to be heard. Next band, now we're down to the 9 megahertz band. This was the weak one, look. Nothing weak about it anymore. The strong 9.33 station we were getting in here, it's down here somewhere. It's off outside of the range of this radio. Quieting down a little bit. Oh. It's a bit of a roll off at the ends of the band, especially near the top. So this is rolled off a little bit, but still getting something. Very good. Yeah, you can hear it getting stronger. Oh, somebody there? Yeah. Brother Stare, giving his view of things. Now, the big band all the way from 6 megahertz all the way up to 18. Pretty quiet. A little odd to be picking something up at 6 megahertz this time of day. Full volume too. This band didn't come out. Okay, so really at this time of day we'd be picking stuff up in this range. Through here.
Responsibility to continue in the path of seeking ever-increasing light. Well, what do you mean by that? Well,
so I think that's 9.333.
The Catholic Church is the old
Uber powerful station. And it's at full volume, so this band is still not quite there. Uy, uy, uy. So the two stations we picked up here and here are here and here now. Wow, of course you got the volume way up on here. Where'd you go?
Las entidades mediadoras del proceso de pacificación. La conferencia.
Yeah, that's coming from Jesus Land down in the States. I don't really know where it's coming from. It's certainly American though. Little ham radio stuff happening here? No. Very hard to tune. Very tight in here. So that's probably 1577, 15770. That's probably my signal generator. Yep, even with the very low, very low setting, and the clip lead's just laying here. Radio's become very sensitive. I don't think there's any doubt of that. And that'll be the end of it up here. So I think that's pretty good. So the purpose of this band, which is basically covering everything, including these three bands, is you can quickly scan the entire shortwave band area, find stations. Oh, this one's at 11 something. Flip up to this band and then tune it in carefully. And this is accurate enough that you can read the actual frequency, right? 11,850, 11,860, 11,870, 11,880. So you could dial in by frequency with this radio. And the other thing I really get a kick out of all these radios. Let me turn a different band on here. All the names of all the cities. Pittsburgh, Hilversum, San Francisco on shortwave, and this guy's not lighting up so well. I'll have to work on the lights a little bit. Rome, Panama, Guatemala, Chongqing. I think the name of that city's been changed. I don't think there's a Chongqing still, is there? Chongqing? Rio? You can't see it. Rio over here. Prague, New York. And what about this one? Havana. Ankara. And I wonder if these were actually true. Ever really true. New York, Boston, Moscow. Schenectady. Really? You'd listen to Schenectady, New York on shortwave? There was a transmitter there? Kind of hard to believe. And down here, so all the bands here are marked on this lower one here. Let's turn it on. So you get a 49 meter band. AMTR. Amateur transmitter. Maybe that's what that means. This is an amateur band right here. Oh, the whole thing means amateur. I'm an amateur at doing this. That's the problem. And 25 meter, there's another amateur, only this time they couldn't fit the TR, so it's just AM up here. Great! So, Magic Eye needs attention. What else needs attention with this radio now? Magic Eye. I think Magic Eye will be the next thing. I think that's what I'll work on tomorrow. Fantastic. In the meantime, this radio's been on for hours today, and we really should get a temperature reading off that transformer, which feels pretty warm to me. 57. 57. So that's reaching the uncomfortable level where you really don't want to, at least I don't want to keep my hand on it. Yeah. Okay. 57's a little high. But you know, it's got these big honking tubes here heating it up. And I have a little fan, which I was cooling off my signal generator since I've been in here so long, which I could put like this. I could put it right like that. But instead, what I'm actually going to do, 57 is nothing to worry about, I don't think, from an electrical point of view. I'm going to do this. That should solve it. Fantastic. Okay, I'm really getting close here. Yeah, that's great. I'm just a little beside myself how this worked out. So I really think I have this radio properly aligned now, and I think it's working really good on all bands. Fantastic. Hey, have a great day. I'm going out to enjoy a little bit of sunshine and yard work. See ya.